Math 3, Practice 2B.1.3, Multiplying Rational Expressions. Okay, so the concept here is that we're multiplying. Remember, when we multiply fractions, we multiply tops and we multiply bottoms. Okay, so the nice thing about this is sometimes we can eliminate things beforehand. Because really, the fractions separate like that are the same as if they were together. Okay, and when we have multiplication, we can eliminate. It's not like plus and minus where you have package deals. Okay, so looking at the first one, if you needed to, we could rewrite this 3 times 5 times x over x times 6x squared plus 9. So the first thing I can notice here is that these x's can eliminate. Okay, I should also have noticed that with this 6, I could, a 9, I could pull a 3 out, right? Because 6 is like 3 times 2 and 3 times 3. So it's really like 3 times 2x squared plus 3. So the 3's would cancel out and we're left with 5 over 2x squared plus 3. Can't simplify that further, so there's our answer. That's as far as we need to go on that one. Okay, number 2, same idea. Let's see what we can eliminate first. Okay, now looking at this, these pluses mean I can't just eliminate the x's. Okay, I can't pull a 2 out of that, so we're just going to have to multiply this one. So x times this whole piece, okay, and then those 2 times together. So we're going to do some area model multiplying here. So x and negative 3, x and positive 1. So x squared, negative 3x, 1x, and negative 3. So the top, x times 2x is 2x squared plus x times 7, 7x. The bottom, x squared, and then positive 1 minus 3 minus 2x minus 3. Now, because these were already split up, okay, we know that we can't simplify this any further. Okay. If we could simplify this, then we would have been able to eliminate stuff here, but we weren't able to, so that's where we're at. Okay, now number 3. So this one we can take a look at and try to see if there's anything we can eliminate first. Okay, so I've got an x squared, but we can't factor it out of anything. Okay, we could factor out an x, we'd have x plus 3 times x, but that's not really going to help us either, is it? Okay, so I don't think we can simplify this one. So we'll need to do some multiplication with the box method for the top one. So x squared, 3x, x squared, and positive 1. So x to the 4th, 3x to the 3rd, x squared, and 3x. So the top becomes x to the 4th plus 3x cubed plus x squared plus 3x. And the bottom becomes x squared times x would be x cubed minus x squared times 4 would be 4x squared. Now, if we look at this one, they actually all share an x, don't they? Every single term here has an x. So we could pull out an x here and an x here and eliminate those. So basically we're left with x cubed plus 3x squared plus x plus 3 over x squared minus 4x. Okay, and that's as far as we could take that one. Which, I mean, I suppose I should have noticed that, but those x squareds are not multiplying it. Sometimes the multiplying does affect things. Okay, number 4. Okay, so this one we should be able to notice. An x multiplied and x multiplied, they can cancel. Okay, 12, let's see, 8 and 4, that's like 4 times 1, that's like 2 times 4. This is like, so we could pull a 4 out and have 4 times 2 plus x over, and that 12 would be like 2 or 4 times 3. So it would be 4 times 3 times 5. 4's would cancel and we're left with 2 plus x over 3 times 5, which is 15. So some of them prove to be a little bit easier than others. Okay, now number 5, what we want to do is we actually want to factor these as best as we can to start off. Okay, and then see what we can do. So factors of negative 12 that would add up to negative 4. 6 and 2, 6 being negative. So we have 2x plus 6 times x minus 6 times x plus 2. If we did the whole area model box method, that's what we'd end up with. Over, now to get this bottom one, okay, it's got the negative 2 out front, but we can pull a negative 2 out, couldn't we? We'd be left with x squared minus 2x minus 15. Okay, so factors of 15 that would add up to negative 2 would be 5 and 3, with 5 being negative. So I'd end up with x minus 6 times negative 2 times x minus 5 times x plus 3. Okay, now we could also pull a 2 out of those ones, right? So that would be 2 times x plus 3. So now you can see there's a bunch we can eliminate. We can eliminate the 2, the negative still stands. We can eliminate the x minus 6, and we can eliminate the x plus 3. So we're left with x plus 2 over, and if we distribute that negative, negative x plus 5. And that's the simplified version. Okay, which is much easier. So you always, when possible, you always want to simplify, and then because we're multiplying, it's like they're all on the same fraction. So really, it comes down to a lot of simplification. Okay, and then multiplication at the end if needed. All right, it says use our knowledge to do the rest. State any. Oh, was I supposed to state restrictions too? Crap. I always forget that. Remember, restrictions for rationals are it cannot be 0 on the bottom because you can't divide by 0. So what would make this 0? 2x squared plus 3. Okay, it would mean x couldn't be, so we could set it equal to 0, minus 3, 2x squared equals negative 3, divide by 2, so x squared would equal negative 3 halves, take the square root of that, so x cannot equal the square root of negative 3 over 2. That's our restriction on that one. Okay. For number 2, because it's in the form of a quadratic, we could use a quadratic formula. But basically, what value of x wouldn't make these work? Easiest thing to do is to graph it and to see where the zeros are, because those are your restrictions. Okay, factors of 3 that would add up to negative 3, 1 and 3, with 3 being negative. So it would be x minus, oh duh, it's right over there, I'm an idiot. So basically x cannot equal a positive 3 or a negative 1 if we were to solve each of those for 0. When you have two x terms in your thing, x cannot equal 0, okay? And another one, could 1 work? No, 1 squared. I don't know if there's any other numbers. 4 maybe? Yeah, because that would be 16, and that would make that 16. So x cannot equal 4 either. On number 4, 15, so no restrictions. Number 5, negative x plus 5. So add x. So x cannot equal 5. Guess I should have been doing those as we go, but I forget a lot of times, so that's alright though. Okay, so number 6, for what values of x is 2x minus 8 over x squared plus 7x plus 10 an invalid expression? So in other words, what do we do to get x to be equal 0? So one way we could do it is to graph it. It would be a parabola. So and then whatever those zeros are, that's what it can't be. Or we can just factor it and say factors of 10 that add up to 7, 2 and 5, 2x, 5x, x squared, 10, which is really 2 times 5, pull out a 5, it's positive, pull out a 2, it's positive, pull out an x, pull out an x. So we'd have simplified, that'd be x plus 2 times x plus 5. Now if we set them both equal to 0 separately, we'd end up with negative 2 and negative 5. So x cannot equal negative 2 or negative 5. Those are the restrictions. Number 7 says, show that the rational expression, all of that, is equivalent to the rational expression x plus 3. So essentially we've got to try to eliminate things here. Okay, first step, we can pull out a 5. So we have 5 times x plus 5 times, we can pull out an x squared, right? X squared times x plus 3 and then x minus 1. Okay, over, we have x times, now this x squared minus 1 is that difference of squares. It's a rule we knew, where it was x plus 1 times x minus 1, right? Take those two and you add and subtract. So we have x plus 1 times x minus 1. And then we have 5 and we have x. Okay, so x minus 1's eliminate. I made a mistake, didn't I? That should be 1. X plus 1's eliminate. 5's eliminate. 2x's eliminate. So we're left 1 on the bottom, because we can always times by 1. So x plus 3 over 1 is just x plus 3. That's why it's the same. Okay, number 8. What simplified rational expression represents the area of a rectangle with the width of x over 2 inches and a length of... Okay, so area of rectangle, we're multiplying basically, right? X over 2 here, 2x plus 1 over x minus 5 here, we times. Okay, then we look, can we eliminate anything? I'm not seeing anything that we can pull out. So we just multiply x times 2x, 2x squared, x times 1, plus x, 2 times x, 2x, 2 times negative 5, negative 10. Now remember, some of us may want to say, well, there's 2 and an x we can eliminate. But because of the plus and minus, they're a package deal. Can't do it. That's our full answer. Okay, number 9. The momentum of an object is the product of the object's mass and its velocity. What simplified expression describes that? Okay, so basically we're multiplying again. Okay, oh, restrictions. Do we say any restrictions? No restrictions here. Those are the two restrictions. Restriction here, 2x minus 10 equals 0. 2x equals 10. Divide by 2. X cannot equal 5. Restriction. Okay, describe the toy car's velocity in centimeters per second where x is greater than 3. Okay, so we multiply these two guys together, right? Now we can simplify these right off the bat. So let's do that to begin with. Okay? So factors of 4 that would add up to 4 would be 2 times 2. So we get x plus 2, basically squared, times x plus 2. Over this one, difference of squares, that'd be x squared minus 3 squared. So following that same rule, be x plus 3, x minus 3. Now, we're just multiplying by all this stuff, so let's just continue that in. Just squish them together. Okay, x squared plus 5x plus 6, factors of 6, 6 and... no, 2 and 3. So we get x plus 2 times x plus 3. So what do we eliminate? X plus 2, one of the x plus 3, one of the x plus 2's, we're left with this. So x plus 2 squared over x minus 3 would be the toy car's velocity. And if x is less than 3, then it would be a negative number, which can't happen with velocity. So that's why we have this where x is greater than 3. And if x were equal to 0, or equal to 3, it would be 0. That doesn't work. So it's once x is bigger than 3 that this starts making sense. Okay, could we take this and change it back to this one? Yeah, we could. But I don't see the point in doing that. I think this looks a lot easier. Alright, last one. what simplified expression describes the volume of a rectangular box with the length, width, and height. So we're multiplying all of them. So let's simplify first. Pull out an x, so x times x plus 1 over x minus 5 times 7x times x plus 1 times factors of negative 30 that are positive x, negative 5, and positive 6. So x minus 5, x plus 6. At the bottom, pull out an x times x plus 7. Okay, so what can we eliminate? An x with an x minus 5, x minus 5, x plus 1, x plus 1. We can't eliminate the 7s or the other x, so we're left with 7x times x plus 6. So let's multiply 7x squared plus 42x over x plus 7. So restriction, x cannot equal negative 7. Which really doesn't make sense. If you're dealing with volume, you couldn't have a negative anyway. But x could not be a negative 7. And there we go, guys.